In the vast depths of the universe, there are objects so powerful that they outshine entire galaxies. These objects are known as quasars, short for quasi-stellar radio sources. When astronomers first discovered quasars in the early 1960s, they appeared as small points of light through telescopes, almost indistinguishable from ordinary stars. Yet something about them puzzled scientists. Their light carried strange spectral signatures that did not match any known nearby object. When astronomers analyzed those signals more carefully, they realized something astonishing. These objects were incredibly distant, billions of light years away from Earth. If that distance was correct, then the brightness of these objects was almost impossible to explain. A single quasar was producing more light than an entire galaxy containing hundreds of billions of stars. At first, many scientists doubted this interpretation because the energy required seemed far beyond anything known in astrophysics. However, as more observations were made, the evidence became undeniable. Quasars were not stars at all. They were the extremely bright centers of distant galaxies powered by enormous supermassive black holes. At the center of most large galaxies lies a supermassive black hole containing millions or even billions of times the mass of our sun. Normally, these black holes are relatively quiet, but when large amounts of gas and dust fall toward them, something extraordinary happens. Instead of falling directly into the black hole, the material begins spiraling inward, forming a rapidly rotating disk known as an accretion disk. Within this disk, matter is compressed, heated, and accelerated to enormous speeds. Temperatures inside the disk can reach millions of degrees, causing the gas to emit intense radiation across the electromagnetic spectrum. The energy released during this process can make the central region of the galaxy shine brighter than all the stars in the galaxy combined. This is what creates a quasar. The light from quasars travels across billions of light years before reaching Earth, meaning that when we observe them, we are actually seeing them as they existed in the distant past. Many quasars we observe today existed when the universe was only a few billion years old. During this early period of cosmic history, galaxies were forming rapidly, and supermassive black holes were growing by consuming enormous amounts of matter. In fact, astronomers believe that quasars were far more common in the early universe than they are today. In addition to the brilliant light emitted by the accretion disk, many quasars produce enormous jets of energy that shoot out from the poles of the black hole at nearly the speed of light. These jets are powered by intense magnetic fields generated by the rotating disk of matter surrounding the black hole. As charged particles spiral along these magnetic field lines, they are accelerated to relativistic speeds and ejected far into intergalactic space. Some of these jets extend for hundreds of thousands or even millions of light years beyond the galaxy itself. When these jets collide with surrounding gas, they create enormous shock waves that heat the gas and cause it to glow in radio waves and X-rays. The result is a cosmic lighthouse that can be detected across enormous distances. In some cases, the energy output of a quasar can exceed 1 trillion times the brightness of the sun. To put that into perspective, imagine a single object producing as much energy as thousands of entire galaxies combined. Yet all of that energy originates from a region smaller than our solar system. This extraordinary efficiency comes from the fact that matter falling into a black hole can convert a significant portion of its mass into energy through gravitational processes. The region surrounding a quasar is one of the most extreme environments known in the universe. Gas falling toward the black hole can reach velocities approaching the speed of light. Magnetic fields twisted by the rotation of the accretion disk become incredibly powerful, guiding streams of charged particles into narrow jets that blast outward into space. The intense radiation produced near the black hole can also push surrounding gas outward, creating enormous winds that flow away from the galactic center. These winds can travel thousands of kilometers per second and may play an important role in regulating the growth of galaxies. In fact, many astronomers believe that quasars help control how galaxies evolve over time. When a supermassive black hole becomes extremely active, the energy released by the quasar can heat or blow away gas that would otherwise form new stars. This process, known as feedback, can slow or even halt star formation in the host galaxy. In this way, the growth of the black hole and the evolution of the galaxy become closely connected. Observations have shown that the mass of a galaxy's central black hole is often related to the size and mass of the galaxy itself. This suggests that black holes and galaxies grow together over billions of years. Quasars therefore represent an important stage in the life cycle of galaxies. They show us what happens when a supermassive black hole is actively feeding on surrounding matter. Over time, however, the supply of gas near the center of the galaxy begins to diminish. As less material falls into the black hole, the accretion disk becomes less luminous and the quasar gradually fades. Eventually, the once brilliant quasar becomes a quieter galactic nucleus. Many galaxies we observe today may have passed through such an active phase billions of years ago. Even our own Milky Way galaxy may have experienced a quasar phase in the distant past. At the center of our galaxy lies a supermassive black hole known as Sagittarius A. Today it is relatively quiet, emitting only small amounts of radiation compared to a true quasar. But if large clouds of gas were to fall toward it, the black hole could once again become highly active. Studying quasars allows astronomers to learn about the growth of black holes in the early universe. Some quasars discovered by modern telescopes are extremely distant, meaning their light began traveling toward Earth when the universe was less than 1 billion years old. The existence of such massive black holes so early in cosmic history presents a fascinating puzzle. How did these black holes grow so quickly? Did they begin as a remnant of massive stars, or did they form through entirely different processes? New observations from telescopes such as the James Webb Space Telescope are helping astronomers investigate these questions. By studying the light from distant quasars, scientists can learn about the conditions that existed in the early universe and how the first galaxies formed. Quasars are therefore more than just brilliant cosmic beacons. They are powerful laboratories that reveal how gravity, energy, and matter interact on the largest scales imaginable. Their light carries information about the distant past of the universe, allowing astronomers to peer back billions of years in time. Although quasars appear small and star-like through telescopes, they represent some of the most energetic and dramatic phenomena in the cosmos. They remind us that even in the quiet darkness of space, extraordinary forces are constantly shaping the universe.